Hello students, welcome to ME515 lecture. So, this is lecture number 2, okay. And this also we are going to talk about chapter number 2 basically. So, we have started chapter number 2 today. Okay. So, what we are going to study today is what is called direct approach. Okay. So, direct approach. Okay. So, what is the meaning of direct approach? Okay. Here this really means there is no differential equation. Okay. No differential equation, and we will have some relationship though, yeah, but not in terms of differential equation, but in terms of something else, but still some relation is known. Okay. Some means we will study in details what we mean. Okay. Okay. So, let us take one example of a spring. Okay. So, this is a spring, two ends, let us name it or number it rather. So, number 1 and number 2, and it has some behavior that we have to know. That means it has a physics basically or mathematical relationship based on that physical law. What is the physics? Physics is you fix the spring at one end and then you apply a load. Let us say capital F you applied, let us say spring constant is k, small k, you applied a load, and if u represents the displacement of the free end, the relationship is F equal to ku. Yeah? Okay. On the left figure, two ends are free, one is not fixed, but still we can write some equation for this one. Equation will be something like F equal to k times u2 minus u1, where u2 is the displacement of point 2 and u1 is the displacement of point 1. Okay. And what is F? If you see on the right hand figure, the F is nothing but a tensile force. So, F is actually tension, right. So, is equal to tensile force. We have a sign convention as well. We are saying positive, all u is positive in when it is going from left to right side. Similarly, for u1 and u2 also we have to specify which way it is positive, and positive when it goes to the right. Okay. And F positive means tensile force, F negative, if you get a negative sign for the force, that means this is a compressive force. But this is the basic relationship, and based on that we are going to go forward. So, when you say F equal to k times u minus u1, this equation we can write in matrix form. And how will we write? We will write this as, what you see is u2 minus u1. So, this will be, you write as minus k times k, not times but k, we are making a matrix basically, and here you will have u1, u2, what you get in this case is equal to F. So, this equation we have written in matrix form. This equation we are writing the matrix form. Why? Because that way it will be convenient, and we will see how it is going to be convenient. Now we want to write these equations little bit differently, and what we mean is instead of specify only one force F, which is a tensile force inside the element, we want to write a force component here at node 2 and call it F2, and at node 1 we call F1. That really means for every displacement there is a corresponding force term. F1 corresponds to U1, and similarly the F2 corresponds to U2. Yeah. So basically if we have now introduced F1 and F2 instead of only one term F, then we have to write it differently, and in that case we will say that instead of writing F here, we can write F, this F, where we are referring to. In this case, if you are writing like this one, if U2 minus U2 minus U1 multiplied by K equal to F, then if F is the tensile force, right, this is the F is a tensile force, and this one basically relates, we can write instead of writing F, which is true for the whole element, we can write here F2. Okay, right here F2. So basically what, same as here, right, here we wrote F is here basically, right. So this F is being written here, then you have a K here, we are writing K here, then U is nothing but U minus 0, this is a 0 here, this U minus 0 because the other end is not is fixed. So that really means what you get, F equal to the K times U. Similarly, we are writing here this F is nothing but F2 because F2 is here, is equal to K, similar way K here. So, you have K here, and then U2 minus U1 same as U minus 0 you have here U2 means U2 minus U1, right. So, like this one, and hence we can write here F2. Similarly, if we have to write F1, how will we write? Okay. For F1, if we want to relate F1, we have to write differently now. Okay. And how? Okay. So, now let us say if you are you have to write F1, how will you write it? The equation that involves here will be similar to this one. So, this one, this F1, if we now write the right figure, what we had, this one if we draw is differently now, means we will fix the right hand side and give a force here, and then we will see accordingly we can write, right. So, we can relate that way. Okay. So, what we can do here is let us say we have a spring here which is fixed on the right side, and you are giving a force this U at this end, okay, and then you are applying a force this way, and then you are then you are going to write the equation for that. And what will be the equation in this case? Okay. In this case also equation will be f equal to k times u, same as earlier. However, here f is what the f means is a compressive force. This is a compressive force now, right? It is under compression, it is going to compress the spring, so compressive force now. Now, let us relate with the original spring system, the spring we had, and we have this was u1, this is u2, right, and then we have k here, yeah, and this is f1 and this is f2, we had f2 here, and what is the equation here now? Equation will be u, we have to now look like the see here, this you have a k here, so k here, then u1 minus u2 is u here, right. So, u is nothing in if you relate to here, u minus 0 will be equal to u1 minus u2. So, we are relating basically, yeah. So, this equation we can write it here as f1 is equal to k, and then you have u1 minus u2, and hence we can write this equation in this equation we are talking about. We can write the whole equation as matrix form, and which will be something like this: k minus k, and then you have u1 u2 is equal to f1. Okay. So, we have now two equation. One equation we have this, okay, let us call it number 1. Okay. So, minus k times u1 u2 equal to f2, and then we have this equation, yeah, and this is k minus k. This is just opposite. The previous case it was minus k and then k. Here it is k first and then minus k, and this remains the same in both of them. And instead of f2, you have f1 here. Yeah. Okay. So, we have the second equation. Let us call equation number 2. We are going to combine them, and our equation what we get becomes k minus k minus k k, and then u1 u2 is equal to f1 f2. So, we have this equation, the first equation, this multiplied by this is equal to this is nothing but the second equation, and this multiplied by this, okay, equal to this is the first equation. So, we got this equation. Okay. So, we have got this system equation. There are two equations basically what you see here, which in matrix form, and this is what we got for a spring, the spring which has a stiffness constant k. There are two nodes where u1 and u2 represent the displacement of the two nodes, and the forces at the node f1 and f2 are the nodal forces, and this is the how the forces and displacements are related. Now, this this is the general purpose. What you see here, this one is known as the stiffness matrix. Okay, so stiffness matrix, Okay, what you see here is this one is known as displacement vector. This one, so displacement vector, yeah, and this is known as the force vector. Okay. Okay. So, we have the stiffness matrix here. This is a stiffness matrix, this is displacement vector, this is the force vector. Okay. Okay. And now we can solve a simple problem, something like, let us say, if the spring is attached like this one, and if the force is, let us say a spring has the stiffness 3, force is 1, we have to find out a displacement at the right end. Okay. So, what is given here, F2 is equal to 1, F1 do we know? We do not know what it is, we have to find out, but what we know is U1 equal to 0. Why? Because this is fixed. So, U1 equal to 0. Here we have to find out at the right end, we have to find out U. So, U2 equal to what, we do not know. So, what we can do is we can use that equation to solve this. We are going to put these things in this matrix system, and we can actually solve that. So, how will we do that? So, we have k equal to 3, we are going to take k equal to 3. So, first we construct the stiffness matrix, then we can write. So, what we are going to do, we will have a stiffness matrix will be 3 minus 3, then minus 3, 3 is the stiffness matrix. Okay. And then we have U1 and U2, U1 is 0, right, and U2 we do not have. So, U2 is like this one, is equal to, and force is given to be F1 we do not know. So, we just write F1 here, and F2 is 1, right, and we have to solve it. Okay. And how will we solve? Okay. Just if you expand it here, what you see is 0, and this 0 is going to be multiplied by this one, 0 will multiply by this one, will make it 0 basically. Yeah. So, that really means is since this is multiplied by this, make it 0, this multiply by this, make it 0. Hence, from the first one basically we are not going to get anything. What we get is simply, so we can just do like this. Yeah. Let us cross it out this. Why? Because 0 is given in here in the first row. So, 0 is going to multiply by the first column. So, we will not use that. This one multiplied by this makes it 0, this one multiplied by this also makes it 0. So, what we have, second equation if you see will be simply 3 U2 equal to 1, right. So, 3 U, that really means U2 equal to 1 over 3, and which is the answer. Yeah. Now, once we have U2 equal to 1 over 3, we can now find out what F1 is. And how will we find out? Now, the first equation we will have 0 multiplied by 3 and then U2 multiplied minus 3, right, and will be equal to F1. So, we get F1, we simply get F1 F1 will be equal to 0 multiplied with 3 minus 3 U2, and U2 is here 1 over 3. So, what we get? F1 equal to minus 1, and this is the answer. So, what it tells you that F1 is minus 1, that really means the F1 is in the negative x direction. So, this is the value of F1 equal to minus 1 units, and that means magnitude is 1, magnitude is 1, and direction is the opposite in the negative x direction. But what you got here, the value of F1 you found out, value of U2 you found out by doing it. Okay, so we have already solved first problem of finite element using the finite element methods. Okay. What we will do now, we will expand this to a more complex problem. Complex problem means little bit difficult. We will make little bit difficult, go step by step. We will make a little bit more difficult, and then more and more, and this is how this course is also organized. So, let us see if there are 2 spring, instead of 1 spring, if you have 2 spring, 1 spring here, then another spring here, then how you are going to do it. Okay.